हेलो स्टूडेंट्स, हाउ आर यू। होपफुली आप सब बहुत अच्छे होंगे। ठीक है बेटा, देखिए हम स्टडी कर रहे हैं डेवलपमेंट ऑफ क्वांटम मैकेनिकल मॉडल। अभी मैंने पिछले लेक्चर में काफ़ी कुछ एक्सप्लेन करा इस पर। ठीक, अब देखिए जैसे मैंने आपको कहा कि ये जो क्वांटम मैकेनिकल मॉडल है या वेव मैकेनिकल मॉडल है, ये बेस्ड है कॉन्सेप्ट्स पे। इसमें पहला कॉन्सेप्ट है डुअल नेचर ऑफ मैटर एंड रेडिएशन। ठीक है, इसमें डिस्कशन की हमने डी-ब्रोगली की। डी-ब्रोगली इज द नेम ऑफ साइंटिस्ट। इन्होंने कहा बेटा जब कभी भी कोई पार्टिकल मोशन में होता है, जैसे अ मूविंग कार, मूविंग बाइक, इफ यू आर प्लेइंग अ क्रिकेट देन द बॉल थ्रोन बाय यू। कहते कोई भी मूविंग बॉडी हो जिसमें मास हो, स्पीड हो, मोमेंटम हो, काइनेटिक एनर्जी हो, अकॉर्डिंग टू दिस कंसेप्ट इट शुड हैव बोथ पार्टिकल as well as wave nature. Wave, that means every moving body has its own wavelength according to this concept. So what is this concept? Dual nature of matter and radiation. According to the de-Broglie, if any particle is in moving state, then it should have both particle as well as wave nature. This is called de-Broglie concept. देखिए, according to the Planck's quantum theory, if we talk about photon or quantum, then the energy of photon or quantum can be written as E is equal to h into nu. H is Planck constant, nu is the frequency. It represents the wave nature of the radiation. That is E is equal to hc over lambda. Nu frequency है, उसकी जगह मैंने पुट कर दिया c over lambda. You know already c is equal to nu into lambda. ठीक है, from here I put the value. Another equation E is equal to mc square, very popular equation given by Einstein. It represents the particle nature because it has mass. Both equations are of energy, so we equate both equations because both are energy, so both should be equal. Now from here you get lambda is equal to h over m into c. That means if any particle is in moving state having mass m, speed c, then it should have wavelength lambda. But suppose we consider general particles like a body, like a car, like electron, like proton, ठीक है? Then suppose velocity or speed is v, then this equation can be modified as lambda is equal to h over m into v. V is the speed of the particle. So wavelength of a moving particle, according to the de-Broglie concept, wavelength of any moving particle is found to be reciprocal to the linear momentum of the particle. M into V is known as linear momentum. This concept, remember, we can find out wavelength of the particle from here. No doubt, you can find out wavelength of any moving particle, running car, running truck, running bike, running train. ठीक है, even you can find out your own wavelength when you are stepping out. But the wavelength for such particles, macro particles, has no physical significance. You can apply this equation for any type of moving particle, but it has physical significance only for micro size electron, proton, neutron like particles. This concept has no physical significance in everyday life, remember this thing. Second, however, it is applicable in all objects but signifies only microscopic particles, that is electron, proton, neutron. Now if you want to modify this equation, lambda is equal to h over m into v, sometimes m and v directly are not given in the question and you have to find out the wavelength. Then how can you find out the wavelength? Suppose kinetic energy of moving particle is given. Kinetic energy, you know, it is half mv square. M is the mass of the particle, v is the speed. So kinetic energy is equal to half mv square. मैंने क्या करा बेटा, इस इक्वेशन में both side m से मल्टीप्लाई करा, m multiplied by m in both sides, ठीक है, and from here kinetic energy is equal to half mv square, 2 इधर लाया, m और m से मल्टीप्लाई करा, then we get m square v square is equal to 2 into kinetic energy into m. From here m into v is equal to 2 kinetic energy into m. Now if m and v are not given directly, then you can find out wavelength by replacing lambda is equal to h over m into v by this value. That means if kinetic energy of moving particle is given, then we can find out wavelength of the particle. In case of charged particle, if any charged particle Q moving in the field applying potential difference V, जब आप किसी चार्ज को पोटेंशियल अप्लाई करते हो तो वो मूव करता है, then its kinetic energy can be find out Q into V, charge into voltage. So kinetic energy can be replaced by Q into V. यहाँ पे replace कर दो, you get wavelength. So from here you get the wavelength of any moving charged particle, any moving particle will have kinetic energy, any moving particle will have some speed p. This is the concept of de-Broglie. So de-Broglie overall explained that any moving particle has both matter and radiation, that is the wave as well as particle nature. This concept is very useful in the upcoming model डेवलपमेंट ऑफ क्वांटम मैकेनिकल मॉडल। इन्होंने जो बेसिक आउटकम दिया वो समझने की कोशिश है। बोहर ने कहा जब कोई इलेक्ट्रॉन किसी ऑर्बिट में घूमता है तो सर्कुलर पाथ में घूमता है। अब इन्होंने यहाँ से एक नया कंसेप्ट निकाल दिया है कि जब कभी कोई पार्टिकल मोशन में होता है तो उसकी मोशन वेव ट्रैजेक्टरी वो एक वेव फॉर्मेट में होगी, मतलब सर्कुलर पाथ में नहीं कह करके हमें कहना चाहिए कि whenever any particle is in motion, it follows some wave type path like this in the wave format, which have characteristic wavelength. उस वेव फॉर्मेट की कैरेक्टरिस्टिक वेवलेंथ भी होगी। तो यहाँ से ये कॉन्सेप्ट निकल के आया जो आगे हेल्पफुल होगा इन द डेवलपमेंट ऑफ वेव और क्वांटम मैकेनिकल मॉडल। ठीक है, दिस मॉडल not only based upon the dual nature of matter radiation de-Broglie concept, but is also depends upon Heisenberg uncertainty principle. So what is the Heisenberg uncertainty principle? Let's see. Okay, so first of all you just watch this video and solve the numericals based on these formulas, and I am sending next video, separate video, in which I will discuss in detail about Heisenberg uncertainty principle. Okay dear? Okay, thanks a lot. If you have any doubt then you can call me. Thank you.